we're going to have to talk about the emission controls on the 6.4. It's a combination of in-cylinder combustion changes and after treatment. Now the EGR is going to work like we've had before. We're going to try to make some improvements on it. We're adding a diesel particulate filter. This is to pick up the soot and stuff coming out of the exhaust. And then we're going to look at the oxides of nitrogen. We'll discuss the EGR now and then the other two later. Here is our EGR in the 6.4. We're trying to make some improvements on it to cool this exhaust gas. What we're going to do is the same thing we've done before. We're going to take hot exhaust gases that's been cooled by our EGR coolers and mix it with our air coming in from our intake from our air charge cooler. We have two EGR coolers on a 6.4. We have one that's horizontal along the side of the engine and one running vertical up the front. Like all EGR coolers, there's potential they may go bad. We've gone through a good discussion of how they work. Let's talk about what happens if they go bad. If either of these EGR coolers go bad, the diesel particulate filter and the diesel or oxidizing catalyst will also be contaminated with coolant, and they're going to have to be replaced. This can get to be a pricey situation. What we're trying to avoid is this carbon, a result of incomplete combustion, which is made up of some soluble organic fractions from fuel and lubricating fluids, and the sulfates from the sulfur in the fuel. One of the reasons we use low sulfur fuel is reduce the sulfates. Here's where oxidation catalyst is going to work. We are coming in the input on the right. As you see the arrows coming through, they have to pass through the medium. The only way they can get completely through, as you can see the one in the back, and the blue one, to get out the exhaust, they must go through these mediums because the channels are blocked off in the back. This is going to give us some back pressure. What we're going to do is we're going to burn off this carbon or soot, whatever you want to call it, by raising the temperature. We're going to decide when we've got to do it by special sensors. And if you get one that's dirty, here's the various ones of people who make cleaners. They backflush, remove out the unburnable material like the ash to try to revitalize them. A number of large fleets are buying them. I think you'll probably see them in a lot of places. Replacing the diesel particulate filter is a very expensive proposition. But let's talk about how we're going to measure things. First of all, we're going to use 3 temperature sensors to make sure we got enough temperature going into this to heat it up and burn off the soot and burnable material. We're going to determine when we need to do regeneration, we're calling it, this burn-off process, by looking at the sensor pressure. We have a pressure sensor that tells us when the pressure is too high, the filter is becoming clogged, and we need to do regeneration, as it's called, burn off the soot. So here's one of them laying out so you can see it with the various things. That's a very pricey piece laying there. We might want to clean it up and reuse it. This is one of our sensors going in here so we can see what's happening, get a view of it. You can look at the temperature and pressure sensor as it goes into the sensor. We have some data here on our exhaust gas temperature. We can monitor it with our scan tool. You can see the red area showing us our 3 temperature sensors. Now these 3 temperature sensors have some critical things to do with engine performance. When we get to the 6.7, we'll go more in detail about how this particulate filter works. But let's talk about this temperature. What's important about this temperature? In order to burn off our accumulated soot and particulates, we need about 1,000 degrees Fahrenheit. We can do this by a process called regeneration. But if we get too much heat, we have to protect the system. In fact, we will derate engine power. Let's talk about that for a moment. If the PCM sees an over temperature condition, where the sensors see over 1,700 degrees Fahrenheit, the PCM is going to derate the engine's power output, and it may shut it down and not let it start for an hour. Now the other kind of cause of this is if the EGT, the exhaust gas temperature sensors, have an open circuit. The computer cannot calculate and determine the temperature of the diesel particulate filter, so it has to derate the engine because it doesn't know what's happening. Now unassociated with this is a couple other things. We can also get low power from low fuel pressure, and we can get derated engine performance because the engine temperature got over 275 at the engine oil temperature. It will protect it. Let's take a moment to talk about regeneration, and we'll get into it more later on. But to reduce the clogging and the backup and the back pressure, we go into a process called regeneration. Let's talk about what regeneration is. Anytime we drive the vehicle and the exhaust gas gets to be 1,000 degrees or so, the soot and particulates that have accumulated will begin to burn off and they'll be gone, and the back pressure will drop again. If we're driving down a highway, we call this passive regeneration. Later on, we'll talk about regeneration on vehicles that are driven in the city lots. But let's look at some of the other things we're adding. We're adding a diesel oxidation catalyst. A diesel oxidation catalyst uses a chemical process to break down pollutants in the exhaust stream before they go into the EGR, turning them to less harmful components and reducing things. This is a normally honeycomb-shaped configuration coated with a catalyst designed to create a chemical reaction to reduce particulate matter, HC, and CO. So the oxidation catalyst works by oxidizing CO, HC, and the soluble organic fractions what we call particulate matter. It breaks it down before we feed it back into the EGR system. So hopefully we've improved our EGR problems with this diesel oxidation catalyst. Here it is here. You can see it on an actual vehicle in the back, and you can see it looking where you just see a little bit back by the firewall. Much easier to see it out here. This is an oxidation catalyst that's going to reduce our particulates slightly, but mainly control our HC and CO.